Okay, imagine this for a second. Imagine handing over the keys to a major hospital's triage system, or a national power grid, or even a global supply chain to an artificial intelligence. The stakes there are, well, they're terrifyingly high, right? But how do we actually know if that AI is ready for the sheer chaos of the real world? Welcome to this explainer. Today, we're going to explore a truly groundbreaking framework that's designed to test exactly that. It's called SystemsBench, and honestly, it fundamentally changes how we measure machine intelligence.
There is this fantastic, powerful quote from the source material that really hits the nail on the head. Capability without calibration is not intelligence, it is hazard. Think about it, an AI that can memorize the whole of Wikipedia or instantly write complex code. That seems incredibly smart, but if it makes blind decisions inside a highly complex, interconnected system without grasping the side effects, that immense capability, it's incredibly dangerous.
Okay, let's dive into this. The absolutely crucial point here is the stark contrast between knowing and thinking. Current AI benchmarks are, they're fantastic at measuring what a model knows. They reward recall, mathematical precision, coding accuracy. Basically, they're just asking, can you get the right answer? But they completely miss how an AI actually thinks. The real world doesn't just want the right answer. It demands an understanding of structure, of feedback loops, of leverage. We need to know if an AI can anticipate unintended consequences before it makes a move.
To understand how we bridge this massive gap, here's our roadmap for this explainer. First, beyond knowing the answer. Second, introducing SystemsBench. Third, the 5 dimensions. Fourth, the leverage ladder. Fifth, a self-improving engine. And finally, sixth, the future of AI agents.
Section 1. Beyond knowing the answer, the limits of AI recall.
So the real world is a messy place. It's full of delays, unintended consequences, unpredictable feedback loops, and that chaotic butterfly effect. In current benchmarks, they completely ignore all of this. Take this classic example from system dynamics called the bathtub dynamics task. It's a basic test of stock and flow inference, essentially just figuring out how water levels change based on what's flowing in and what's draining out. It's kind of wild, but studies show even highly educated MIT graduate students frequently fail this basic test, which just goes to prove that raw general intelligence, whether in a human or an AI, does not automatically equal systems intelligence.
Section 2. Introducing SystemsBench, a new paradigm for evaluation.
Enter SystemsBench. This is an open-source framework led by Ember Sioni and August Domenchuk over at Outlier.Systems. They designed it to solve this exact problem by measuring a specific construct they call STLC. That stands for Systems Thinking and Leverage Competence. So what does that actually mean in plain English? Well, it's the capability to look at a totally messy situation, identify the actual boundaries of the system, predict how it's going to behave over time, and then devise high-leverage modifications to get a desired effect. We are grounding AI evaluation in deep, deep academic rigor here.
All right, Section 3. The 5 dimensions, the anatomy of systems intelligence. Now, what's really interesting about this next part is how we break down the scoring. Because systems intelligence isn't just one single skill, it's like a giant puzzle. It's layered. Stratum I is perception. Can the AI even see the system? This covers dimensions A and B, which are all about mapping boundaries, structures, and loops. Then you have stratum T, which is dynamics. That's dimension D. Can it reason about how the system moves through time, accounting for delays? Stratum 3 is intervention, mapped to dimension C. Can it change the system wisely and actually make it hold? And cutting across all of this, the entire shebang, is the epistemic calibration layer, dimension E. This is asking the big question: does the AI actually know the limits of its own knowledge, or is it just guessing with false confidence?
Now, out of all those dimensions, dimension C, leverage placement, stands out. It holds a massive 30% of the total score. Why? Because finding the exact right place to push within a system is literally the hardest to fake competence. Look, an AI can easily spit out complex jargon, but correctly locating that one single point of intervention that actually solves the problem, that is true intelligence.
Moving to Section 4, the leverage ladder. Where does the AI push?
This right here is where the theoretical meets the highly practical. The number 12 is absolutely central to this. SystemsBench grades AI using the famous systems thinker Donella Meadows' 12-point hierarchy of system intervention. It acts as the ultimate grading rubric for the AI. It's basically a ladder ranging from the lowest, least effective ways to change a system, all the way up to the most powerful, high-leverage points.
And this brilliantly illustrates the difference. At the bottom of the ladder, low leverage points are just tweaks to parameters and constants. Think of an AI just suggesting we change a tax rate or maybe a subsidy. I mean, it's easy, sure, but it rarely fixes the underlying system. The top of the ladder, though, the high leverage points, those involve changing the system's actual rules, its overarching goals, or even the whole underlying paradigm. So an AI that just changes a subsidy is going to score way, way lower on SystemsBench than an AI that identifies a structural flaw and completely rewrites the rules of the game.
But you might be wondering, how do we ensure this grading is fair, especially for complex open-ended questions? Well, SystemsBench employs a very strict fail-closed rule. If the AI judging panel isn't mathematically calibrated and in strong agreement on a complex item, it simply reports it as uncalibrated. It just refuses to score it. As the framework itself states, a blank is honest, a fabricated number is not. They literally never silently average away disagreement just to produce a neat final score.
Section 5. A self-improving engine, the living benchmark.
Okay, this is where we hit a real technical breakthrough. SystemsBench is not a static PDF. It's not a fixed set of questions. It's a living, breathing software organism. Meet Devara. Devara is the AI entity that actually operates the benchmark. It runs this recursive loop called a sense run to continuously improve the test itself. As AI models get smarter, Devara ensures the benchmark evolves faster than any large language model could ever possibly memorize the answers.
Every single time Devara triggers a sense run, it executes 5 core steps. First, it senses the current state of the benchmark and critiques it to find weaknesses. Second, it researches prior art and proposes one exact high-leverage change. Third, through a super strict gate, it reviews the proposal. Fourth, if it passes, it applies the change and calibrates it to ensure quality hasn't dropped. And fifth, it logs everything and recurses. So through this whole process, Devara is autonomously pruning weak, easily guessed questions and dynamically creating brand new, harder ones.
So what's the takeaway here? Why does this self-improving engine matter to us? Simply put, static tests give us a false sense of security. If a test never changes, models will eventually just memorize the answers, and they'll look vastly more capable than they actually are. SystemsBench, on the other hand, acts like a living immune system. Because it evolves and compounds in difficulty with every single run, it keeps the AI honest. It measures true capability, not just good test prep.
Finally, Section 6, the future of AI agents, trajectory grading.
The development of SystemsBench is happening across 3 horizons. In the near horizon, the focus is on populating a human-labeled gold set of answers to lock in the grading accuracy. In the mid-horizon, we see fully autonomous pruning, where the question bank improves without a human in the loop. But the really thrilling part, the part that changes everything, is the far horizon, agentic trajectory grading. This is where AI won't just be answering text-based questions on a screen anymore. Instead, the AI will be dropped into live simulated systems and graded dynamically on its actual behavior and its real-world interventions over time.
Ultimately, all of this complex architecture, the leverage ladders, the living engine, it all distills down into one thing, the systems quotient, or SQ. And to be clear, this is not just a raw intelligence score. The SQ is a comprehensive profile of an AI's safety and capability in the real world. A model that reasons brilliantly but completely fails to realize when it's wrong, that model cannot achieve a high SQ.
Which leaves us with this final, incredibly provocative question to ponder today. As we inevitably start handing over the reins of our most critical infrastructure to intelligent agents, we have to ask, when artificial intelligence changes one thing, does it understand what else moves? If it doesn't, we are literally flying blind. Thankfully, SystemsBench gives us the tools to finally see clearly. Thank you so much for joining me on this explainer. Keep questioning, keep learning, and I'll see you next time.